All right. Hi, everyone. Sorry I'm out today. My son has a double ear infection, so just one more joy of being a parent, having to deal with those double ear infections where you lay them down to go to sleep and they scream. It's lovely. But I will be back tomorrow. So, to try to keep our education continuing and making sure that we are getting the best math education possible. Today we're going to continue on with section 9.7, which is solving systems. I'll write it up here, solving systems of linear, oops, if you can actually see where I'm writing, whoops, there we go, of linear and quadratic equations. Okay, let's focus, come on. Jeez, doesn't want to focus at school, doesn't want to focus at home. See if bringing it down a little closer helps. It's probably a matter of bad lighting where I am. There we go. All right. So the last time we saw the phrase systems of equations, we were dealing with just systems of linear equations. We would have two linear equations. And when we worked on that chapter in the first semester, we saw how we would draw two lines. Okay, those aren't the two lines, those are my axes. But I'd have a line like this and maybe a line like that. And I was trying to find their intersection point. That would be my solution. And we also saw how sometimes the lines never intersect if they're parallel, or if they are the exact same line, there's infinitely many solutions. But now we're dealing with linear and quadratic equations. Linear is going to give us a line for our graph, but a quadratic is going to give us a parabola. So when we're trying to solve these, okay, we could have, here's my parabola, here's my line. We could have two solutions because once again, we're looking for those intersections. Where does the line intersect the parabola? So I could have two solutions. Okay. There also could be a point, a single point where the line touches right here. This would be called a tangent line. We'll learn about those in geometry. But that tangent line would mean we'd have one solution. And then it's also possible that, here's my parabola again, here's my line, they never come in contact with each other. So we could have no solution. And really, the way we're going to be solving this is some of the ways that we've already solved problems on Delta Math. The book goes over a couple different methods, and I'll deal with those when I'm back with you in person. Um, One of the ways they talk about solving them is doing the graphing. We will do the graphing, but not today. I'll do that with you together. But what we will deal with is um, basically it's called the substitution method for this, but I just call it setting the equations equal to each other. So let us take a look. We've got two equations over here. Y equals x squared plus 1, and y equals x plus 3. And our goal is we're trying to figure out when these lines and the parabola intersect each other. When do they cross paths? So we really just want to know when are they equal to each other. So if this was our system, okay, here's our linear, here's our quadratic, since we're dealing with linear and quadratic equations, if we're looking for when they cross paths, we just want to know when are they equal to each other. So we would say, hey, when is x squared plus 1 equal to x plus 3? And at this point, you might be thinking, well, now we have just one of those situations where I have to get it equal to 0. And you're right, that's what we got to do. We got to combine everything so that one side is equal to 0, and then we'll be able to use either our x factoring or quadratic formula. So let's subtract x from both sides. Let's subtract 3 from both sides. And that gives me x squared minus x minus 2 equals 0. All right, so there is our equation that we're ultimately trying to solve. And the solutions to this will be the values of when these two equations are equal to each other. So we could jump right into x factoring or the quadratic formula. I always like to check x factoring first because if x factoring works, well then we're going to have an easier time. So a times c, that's 1 times -2, that's -2. B is a -1. Is it possible to have two numbers that multiply to -2 and add to a -1? Well, yeah, actually it's -2 times a +1. A is 1, so we'll divide by 1. And my factors are -2 and 1, which means my solutions are x equals +2 and -1. So at those values, our equations are equal to each other, and they will cross paths. We will have two solutions. It would look something like this. Not too bad, hey? We just take the equations, set them equal to each other, and then use either x factoring or the quadratic formula. Okay, let's try another. This time we have y equals 5 minus 0.5x squared, and y equals -0.5x plus 2. So this one's not as nice because we've got some decimals, but that doesn't mean it's not, we can't do anything with it. That's just probably a good one that we'll have to use the quadratic formula for as opposed to x factoring. But let's see what we get. I want to know when these cross paths, if they do, so I'm going to set them equal to each other. 5 minus 0.5x squared equals -0.5x plus 2. This time I'm going to move everything to the right because I like having my x squared term, which will be my leading term. I like having that be positive. So I'm going to subtract 5 from both sides, and I'm going to add 0.5x squared to both sides. Now remember, I can't combine these two because this is an x squared and this is an x. So 0 equals 0.5x squared minus 0.5x minus 3. And looking at this, yeah, this isn't going to work out too nicely because of the fact that we've got some decimals here. So x factoring is not going to be possible. Quadratic formula is where we want to go. So a is 0.5, b is -0.5, and c is -3. So what do we got? X equals the opposite of b, so 0.5, plus or minus the square root of b squared, so -0.5 squared, minus 4 times a, which is 0.5, times c, which is -3, all over 2 times a, which is 0.5. Okay, now we either got to bust out the calculators or do some mental math. -0.5 squared is positive 0.25. 4 times a half is 2. 2 times -3 is -6. And we're subtracting that. So minus a -6, which means plus 6. And that gives me 6.25. And then 2 times a half is 1. So we're getting x equals 0.5 plus or minus the square root of 6.25 all over 1. So I really don't even need that all over 1 anymore. It's just this. So now we just got to see, can we simplify this down? And believe it or not, 6.25 actually, I would consider it a perfect square. It's a nice number. Square root of 6.25 should be 2.5, which it is, 2.5. So this becomes 0.5 plus or minus 2.5. So what do you know? 0.5 plus 2.5, that's 3. 0.5 minus 2.5, that's negative 2. And there's our two solutions here. X equals 3 and negative 2. So, all right, that's really all there is to what I want you to work on today. Setting those equations equal to each other, getting it equal to 0, and then solving using either x factoring or the quadratic formula. If you have any questions while you're working on this, please don't hesitate to email me. I will get back to you as quickly as I can. And as I mentioned earlier, I will be back on Tuesday. Good luck and have a good day.